Hello guys, welcome again to Foodie James channel, where I try to make educational technology easy for you. And now guys, I want to respond to a question I was asked by a friend, and that question is about how to use R to compute analysis of variance. And I want us to respond to this question, guys. Using R, an experiment was carried out to measure the power output of solar panels mounted at different angles. 4 different angles were used for each of 5 different types of panels, with 2 duplicate panels for each combination. And the data obtained were as follows. And now the first question was to perform a two-way analysis of variance to examine whether this data suggests that the output is affected by the angle of elevation. We may state the appropriate hypothesis. Now, when we are told to conduct a two-way ANOVA, what we are trying to analyze here is the main effect of the angle and the main effect of panels simultaneously at the same time. So the first set of hypotheses, for this case, because we want to test the effect of angle of elevation, the null hypothesis will be that the effect of the angle of elevation is not significant, versus the alternative hypothesis that the effect of the angle of elevation is significant. So guys, I want to show you how you key in this data in R so that now you can execute your analysis. So I want to open my R program, guys. I want to open my R Studio. I'm going to use R Studio, guys. So from here, the best way you can key the data, you can start by keying in the measurements, the Y variables which are in here, which you can comfortably call the 4 different angles were used. Panel, each combination, the data was obtained. So this is power output. Whatever you have inside the data is power output. So you can have power as your first variable. Then you can key in all the values you see, in that table. What are those values which are in there? You can key them. And so guys, I want to simplify everything so that we take shortest time possible. So what you can see here is all the values inside the table. I have just organized them in several columns so that to make it easy for you to see and to avoid omitting values. Then the next variable we are going the next variable we are interested with is the angle, and to save and the panel. To save time, I just quickly type the variables here so you can see the angle. That's how you key in the data. The angle happens in 3 levels. The first level is 0 degrees, then 10 degrees, then 20 degrees, and 30 degrees. So those are 4 levels. The pattern appears in 5 levels, 1, 2, 3. So you must key in such a way that the first value corresponds. The first value, 42, corresponds to a level of 0 and a level of 1 in the panel. So if you just continue all the way to the last, you realize that the last value in the table corresponds to the last value, which is 30 degrees, and corresponds to a value of 5. If you make sure that those things as they are, then the data is well keyed in R. So now, to conduct the first question, in the first question, you are asked to perform a two-way analysis of variance. To conduct the two-way analysis of variance, you can call it ANOVA 1. Then in this ANOVA, I want you to use the function for ANOVA. Then you remember you are using power as your independent variable. Then after you use the power as the independent variable, you're increasing it to angle. These are your independent variables plus panel. So by doing that, R will compute that. You can now request summary. If now you run this thing all together, then sorry, I see I've typed M instead. That one should be that. So here goes your ANOVA. So this ANOVA, that's your two-way ANOVA, and from it you can see that the anchor has got 1 degree of freedom, the panel 1 degree of freedom, and the residual, the p-value for the, remember we are testing the effect of angle of elevation, testing the effect of the angle of elevation, which is here, and you can see the p-value is less than 0.5. So it's the effect is effective, it's significant. Now, for the second part, we asked whether it is possible to test the interaction effect. And if yes, then we perform. Definitely, because we can see we have two levels, we have two variables at different levels, then there is possibility of us testing the interaction effect. And so I want to show you how you test the interaction effect in R. So we are now going to have another ANOVA model 2, which in this case will be, we use just the normal function for ANOVA. We are still going to use the Y variable. Then we are going to have then we have the main effect for the panel. Then we are going to have the joint effect of the two, or the interaction effect, which you are going to write like that. With that, you can now request for summary of ANOVA. And if you highlight this, then run it, you have ANOVA with the main effect here. You can see the main effect. You can see the main effect for angle and panel here. Then you can also see the interaction effect expressed here. In this case, interpreting the interaction effect, you can see the F value is 0.137 with a P value of 0.7134. The P value is greater than 0.5, so we fail to reject the null hypothesis, and we conclude that the interaction effect is not significant. And that's what is all required for that question, guys. So you can be very keen on the answers produced by R for that question. You'll be able to use my interpretation to write your conclusion that the interaction effects was insignificant because you have failed to reject the null hypothesis. And so guys, I'm happy, and I hope you're happy. And please remember to subscribe to my YouTube channel, and so that in case you have another problem, you can easily reach me, because I'm here to help you. So we are statistics. I'll be doing several videos for this one. I'll do other videos to use R, Excel, SPSS, any of those statistics softwares. I'll be able to show you. So we meet on the next video. Thank you, guys.